occipital fascicularis, longitudinal fascicularis. These are the areas, but hugely, hugely significant differences between the monolingual and the bilingual brain. So these studies are showing that being bilingual changes a lot about how your brain is structured. It changes a lot about how brain functions, and cognitively as well as linguistically. I identify the 4 structures of interest here, 2 in the auditory area, Wernicke's area, the superior temporal and the middle temporal gyrus, the 2 Broca area, opercularis and triangularis, and the arcuate for this is this individual's brain. What you'll see next is the rendering from volumetric data created by Ray Ramirez in MATLAB. You see the response to the standard stimulus. On the bottom, auditory and Broca's activity, the current strength of the current is shown. And here's the English deviant comes, and you can see more activation in Broca's to the new sound, the deviant sound. And then the sound that is not contained in this adult's language, the Spanish deviant. Now in 3D, on a 3D monitor with your black glasses on, this is very, very, very compelling. You feel like you can reach out and touch it. So I'm stopping the film just to see that the 2 deviants are promoting more response, especially early in Broca's, in comparison to the standard, which is repeated over and over in the experiment. Okay, so again, in this adult, you can see activity is greater in Broca's. Now let's look at the 6-monther. Here's a single 6-month-old baby. Again, free surfer, but it takes special rendering to produce these data in babies. The structural data, superior temporal gyrus, middle temporal, the opercularis and triangularis, and the arcuate. And the movie showing MEG activation for the baby to the standard. More activity in general and more activity in comparison to the adult in the Broca area. Synchronized activity, a lot of it, for the English deviant sound. And then you see the Spanish deviant early reaction in Broca's to that signal. And then again, high levels of activity in both areas. And here we focus just a bit on a place where you can see the Broca area activity to the 2 deviants. Okay, now I want to show you the 12-monther. So here we have the 433 areas, 2 areas of the auditory system, 2 areas of Broca's area, which is responsible for listening and talking, and the arcuate that connects them. Now I'm going to show you what does the brain do. The bubbles that you see as the current flow as a word in English comes by. The red bar at the bottom, the auditory activity. The blue bar is Broca's area, which is getting ready to talk back. You can see that both are active. Here's a new English word. Again, auditory area is very active. Broca's area also active at the same time. That pathway is active. Now here's a Spanish test word. So Spanish is not this child's language. What we see is same activity in auditory. The auditory system's reporting it, but actually greater activity in Broca's. What we're interpreting this finding as showing, babies, as they listen to us talk, want to talk back. Broca's area is getting ready to talk back and it's trying to simulate. It's like analysis by synthesis. They're getting ready to talk back. If it's a brand new language, it's harder for the child to know, how would I talk back to that Spanish sound? At 12 months, the child already knows the difference between Spanish and English and is reacting differently to the 2. So the baby brain is being shaped in this early period. By 12 months of age, babies have sorted out the languages. They're ready for a new language. They could operate with 2. In bilinguals, you see activity in Broca's that's equal for the 2 languages. In 6-monthers, it's equal. But at 12 months, they've begun to select which is the language that I'm learning, which is the language that I'm going to respond to. Okay. Developing children, so these are various electrode sites in typically developing and toddlers with ASD.
These are 2-year-olds. So in 2-year-old typically developing, you see a highly focalized response at T3 separating known and unknown words. You do not see that in group data with children with ASD. However, the ASD kids vary greatly. If you take this measure, this looking for responses at T3 to the known words with the children with autism and use that as a predictor, then 2 years later and 4 years later, the children who had better responses at T3 are the ones who show excellent. Okay, so here is this is the kids who are better socially and poorer socially. You can see that it separates them, but this is the interesting data.
Boxes is their outcomes at year 4. They're 4 years of age. They were measured at 2. The bottom row shows their abilities at the age of 6. And the various columns show cognitive ability, then adaptive behavior, and receptive language. What's amazing about this graph is that the measure taken at 2 gets to be a better predictor over time. What we think is happening is that the measure at 2, the ability to acquire the name of a thing, it depends on your attraction to people. You have to learn from people to know that the name of this in English is watch. You have to interact with humans speaking English. In Japan, it's named differently. In Russia, it's named differently. So this probe at the age of 2 to learn words is a kind of probe of your ability to learn socially. Learn this language. Boxes is their outcomes at year 4. They're 4 years of age. They were measured at 2. The bottom row shows their abilities at the age of 6. And the various columns show cognitive ability, then adaptive behavior, and receptive language. What's amazing about this graph is that the measure taken at 2 gets to be a better predictor over time. What we think is happening is that the measure at 2, the ability to acquire the name of a thing, it depends on your attraction to people. You have to learn from people to know that the name of this in English is watch. You have to interact with humans speaking English. In Japan, it's named differently. In Russia, it's named differently. So this probe at the age of 2 to learn words is a kind of probe of your ability to learn socially. Learn this language.